you know, you guys are a really good audience because the people I work with at Anki are not nearly as understanding. They don't understand why the CPU budget is so low, and they say it's a $180 product. You know, I bought a $35 Raspberry Pi. Can't you just toss one of those in there? And maybe you guys know this, but like, you know, you start with $180, then the retailer immediately takes $60 off the top. That's just how it goes. So then your company has to make payroll for about 200 people in Anki's case, so then we have to take like half of what's left. Then the factory takes their cut, and all these little bits and pieces, plastic and gearboxes and screws, they need to be manufactured and assembled and tested. That's not cheap. And then you have to subdivide like the little bit of money that's left between motors and batteries and cables and manuals and packaging and taxes and shipping. And you know, there are hundreds of components in Cosmos, so the CPU gets like its little bit that's left. So anyway, I'm way off tangent. Point is this. You can't possibly know the real cost of a product until you build it. And I mean, even after building the XV11, where I learned a lot about costing, I was way off on Anki Drive, I was way off on Anki Cosmo, I was way off on Anki Vector. Like, I'm not getting any better at it, and it's not just me either. It's just that every time you're pushing the envelope and you're building a product that nobody's built before, like, our factories don't know what to do, right? Like, we went to toy factories, and they're like, well, we can't use these cell phone parts. We've never built something with Wi-Fi before. So we went to, you know, cell phone factories, and they're like, well, what is this, a laser printer? You know, I mean, you've got all these motors and gears and all this stuff, all these fine calibration and optical encoders. Like, nobody knows how to build these kinds of things. And so until you've built a few 100,000, then you really start to figure it out. So this is the new product. This is Vector. I brought one here straight from the debug lab. And so it's shipping in 2 weeks, so I'm kind of busy right now. But you'll probably notice we recycled like a lot of stuff from Cosmo, and a lot of it was just because like it was so much effort just to get everything working mechanically in Cosmo that we decided that we would put the mechanical engineering team on a longer schedule for the next robot, and then focus on the guts. So even though it looks like we recycled a lot, it's not as much as you think. Because the first thing we did, thanks for anticipating my question, is we put the brains on board. The one thing everybody wanted was an onboard CPU that cost more than $4. So the price had to go up, but it wasn't that bad. For a moderate increase in price, we could get a quad-core 1.2 gigahertz ARM with 4 gigs of flash and half a gig of RAM, which, you know, is pretty great for a guy who's programming a 128 kilobyte Mac, but the software team says it's not nearly enough. But the important thing is that now the robot is always on, and so it's not a slave to your phone or your app. And the other really cool thing that we can do with this robot, now that we are targeting a specific CPU, is we can use all those cool accelerators your phone has that only your phone has and the next guy's phone doesn't have. So the particular CPU we use is this Snapdragon, and it has a hexagon DSP with special deep learning instructions and a weird compiler that's not supported by anybody, but we can use it because it's our CPU and our robot. It also has like a GPU with OpenCL, with certain classic performance and all that kind of stuff, also with deep learning instructions. They thought 2 sets would be better than 1. So we can do onboard deep learning now, which is pretty cool. We can also leave the robot on the cloud, which is something it can do as well. So we're already using the cloud in Vector. We use it for speech processing and some of the heavier duty AI functions. But it's not necessary. You can still interact with the robot without it. It just becomes just like a little bit less smart. The other thing is sensing technology just keeps getting cheaper. It's amazing to me that like half of the people who demonstrated their robot today talked about the VL53 time of flight sensor. There's one right there. Because it's cheap now, and it gives you this amazing capability you didn't have before. And so now this guy can, much like you were discussing before, can sweep the table and figure out where objects are and things like that that he couldn't do before. and augmented with the vision system. There's a lot of really neat stuff we can do. Anyway, the deep learning stuff is probably the most exciting to me because it's like this weird voodoo magic. I mean, some of you guys probably understand it, maybe, or maybe like the more you understand it, the more magical it gets. I'm not sure, but like one of the things Vector does on board with his deep learning accelerator is he looks for people because he's a social robot. He likes to find people. And so this is an example of him running his people detector. And like, it's so weird how he knows what a person is. From like the underside of the chin, he's like, yeah, that's a person. From like the back of a bald head, he's like, yeah, that's a person. Or like a face off in the distance, yeah, that's where the person is. And you know, earlobe, yeah, that's probably a person. You know, beardy guy, you're like, whatever. It like pretty consistently can spot people in the room. It doesn't confuse a chess piece for a person or anything like that. And so, and it works in all kinds of lighting conditions. And really, it's just sort of like, this is stuff I always imagined computer vision could do, and now it's actually doing it on board on the robot. This example is just super exciting to me, but it takes a little bit of explaining. Basically, this onboard neural net can distinguish between boring things, like flat level surfaces and things that are off in the background that it can't interact with, and interesting, novel things that are up close. And you can see in this video I'm about to play sort of like parts of the video are lighting up, like this guy's face and forearm are lighting up. If it's lighting up, it means that the neural net thinks, that's interesting. That drives the robot. It helps the robot find interesting things. But you can see like ceiling lights, whatever, they're not interesting. This flat table, who cares about that? Oh, that monitor's kind of cool. Maybe these wires and outlets are cool.
Is this coming from a log or is it streaming?
This is streaming. This is a video from a
user can watch this stream? Or?
Oh, it's a good question. I mean, we can, obviously, with our tools. We'll maybe expose it in the UI. I don't know much about what we're going to expose to the UI. But anyway, what I think is just so personally cool about this is that it's the thing I wanted to build but could never figure out how to build. I wanted to build a curious robot that would actually, when something interesting goes around, would go check it out and could just spot novelty. And like, you know, how does that work? I don't know. It's deep learning magic.
How do you define interesting?
That's the problem with deep learning, right? Like, we trained it on stuff that we thought was interesting, and then it started finding interesting things in the environment.
Oh, I see.
So,
I see.
Yeah. Oh, please go ahead.
Yeah. Are you like fully pre-trained on the neural nets, or are you doing any like learning on board, or like using customer data to train in the cloud, or anything like that?
We're not using customer data that way. We have to be super careful with customer data, and actually that's something I'm personally like extremely paranoid about because I don't like the idea of a roving cloud camera in my house. But maybe I'm just a fuddy-duddy. But anyway, so we don't do that kind of online training, but instead what we do is we have sort of like an opt-in beta program where people can collect stuff for us and we can analyze it and then we can use that to sort of like figure out how we want to train up our stuff offline. So. Oh yeah, sorry, please go ahead.
What's the price difference between the two robots?
I should have been prepared for this question, but as the engineer, I'm probably gonna get punched by somebody. I think we're aiming for $249 right now. So obviously that's very different from the cost difference, which I'm intimately aware of. But anyway, it's totally worth it because we added these microphones, there's like a directional microphone array and all these new sensors, and so it's all worth it.
Cosmo is $200.
Yeah, it's like 180, it just depends, but yeah. So it's really cool that we can run all this stuff on board, and it's like we're just getting started. Like I said, one of the things Anki does is we release major software updates every year, and then sort of like minor software updates every 3 months. And so like the stuff we're already doing with this in the lab, this is what's actually in 1.0, but there's already amazing things we can do with the deep learning on board.
Do the updates go to the customers or just to the factory?
They go to the customers. That's one of the cool things about having a cloud-connected robot. With Cosmo, if you downloaded the app, then the app, you'd always get the latest version. The app would update your robot. But with Vector, he's actually online. He can update himself. And so he sort of stays up to date with the latest, greatest software all the time. So, and so anyway, this is a marketing slide. I couldn't make something this pretty, but it's basically an illustration of what I'm talking about by like Anki's bottom-up approach. You know, we've been funded for 6.5 years now. We're releasing a new robot every 2 years. We're releasing major software updates every year and minor updates every few months. You know, we built out the company. We have all the departments and processes, and I think the company is kind of like the machinery to build and sell these machines, and keep up with the cadence, deliver things on time. We have this software stack that's growing constantly, and cloud services that will all come online for Vector. And we have this big SDK, which I hardly mentioned, but it's something I'm very passionate about, Camp will tell you. But I'm a big believer in making these robots accessible to anyone who wants to run them for research or whatever. With Cosmo, we run this big education thing. There's like a Python SDK where you can get like color video out of it and do all kinds of things that like actually the real Cosmo app can't access. And so the SDK is even ahead of what's provided to the app because we're just really believe in making cheap platforms available for people. Please go ahead.
I was kind of curious.
Yeah.
You saw, it seemed like a huge step up with the onboard GPU, deep learning, all the sensors. Do you have any inkling of what the next step after that's going to be, or do you think it's going to be a while of iterating on software and making it smarter? Your best guess for the future, next step up after this?
Well, our next product, which you can see is to be announced in 2020, is already in my office right now. And I'd love to tell you about it, but I can't. So anyway, I can answer your other questions though. So.
I saw you had education on that roadmap, and you mentioned education in terms of programming, but a big chunk of the toy market has always been preschool, kindergarten, reading kind of education. Are you focused at all on that?
Yep, we actually do have that. So in fact, every Cosmo comes with Scratch, and we have the little version that's just like all iconic. There's no coding understanding required, no reading required, and people can sort of like iconically control the robot, make it do simple challenges and patterns. And then there's full-blown Scratch where you can have loops and stuff like that, where we have like 9-year-old kids that are making better games than some of the games we bundled with stuff using Scratch. And so, and then on top of that, we have the Python SDK, which is really raw. It basically gives you like the raw IMU data, the color video feed, the PID settings, all of that stuff. So,
but my question is, I understand and I fully support that, but what about like vocabulary for
I see
preschool?
what you mean. We're not doing that right now, but it is something that we're interested in talking to people about it. So especially if you have more ideas, maybe we could talk a little bit more after, because you're not the first person to ask us about this. Educators, I think, are really, there are other kinds of people with certain special needs who may be able to be more comfortable practicing with a robot as opposed to a person. We hear a lot of this stuff, so I know I'd be interested to hear more. So thanks. Yeah, go ahead.
Can you do like peer-to-peer communications if all these communicate together?
Yeah, so this is something you can't tell anybody I told you. We designed it to do that, but there's no software for it. So one of the most depressing things about being a hardware guy is that we can put cool features in way faster than the software team could ever keep up with us, and so there actually is a peer-to-peer.
So you're saying I can approach you after this and you can tell me?
Well, maybe. I mean, and maybe it's accessible via the SDK. I actually don't know the answer to that, but it does have abilities, and obviously Vector is full-time has an IP address, right? And so if you have the right crypto key to connect to his SDK, then it's possible for robots to coordinate with each other and do all kinds of interesting stuff. So.
Thank you. Another question.
Yeah, sure.
So there's a big upgrade from last year's device to Vector. I know like everything scale up in the electronic side. How do your battery scale up with all this?
Oh, stab me through the heart. Yeah, so that's way too insightful. Yeah, basically, I don't know, I have a lot to say about that. The official line is it's 40 to 60 minutes of battery life off charger, and the Cosmo was something like 100. And so it really does make a difference. Like you say, it's the same little guy. I wanted a bigger battery, but they get less and less safe the bigger they get, so we ended up not going that direction. Anyway, my understanding of it is that because this guy, his vision system is super great at finding the charger, and the other thing about him is he's got like way better cliff sensors. He's got this more modern technology in 4 different locations on the bottom and everything, so he can basically drive around without there being any worry about him falling off a surface. And so, so anyway, as a result, people feel more comfortable letting him go back recharging, all of that stuff kind of automatically. So, yeah, go ahead.
Do you have to do any sort of safety certifications?
Tons, absolutely. I mean, like you could eat 5 Cosmos a day and have less lead in your system than like 1 breath at the playground. I mean, it's like the lead standards, the mercury standards, they are super strict for toys. And so we had to do like all of that kind of stuff. Obviously, another thing is that you may not know about is like a lot of countries now have SAR, which is specific absorption rate, and that's to protect people from Wi-Fi radiation. And so the antenna is right up here in its head because it's a really good place to pick up Wi-Fi signals. But if you like to nuzzle your Vector or whatever, then you can be assured you're not going to microwave your brain. So
That's good.
So I've been following the development of Cosmos since back before it even launched.
Yeah, okay.
And one of the things I found really interesting was in the storyboard section there were different scenes on how Cosmo could be planned out with different people. You pick him up. There was a scene where he sings the Superman theme and he gets really excited, and if you drop him, he gets really upset. I'm curious on if Anki has been looking into different engagement models for children versus adults, given that this is a social robot designed for different people.
Yeah, we do a lot of that. Unfortunately, it's not really my area of expertise.
Could you repeat the questions? We
Oh,
can't hear.
oh no, oh yeah, sorry about that. I think to summarize the question, stop me if I'm wrong here, is basically like Cosmo has a lot of sort of like child-focused interactions, and Vector, one of the things we're actually talking about is like maybe adding on top of that a layer of more sort of like utility functions and things that might be more appealing to what marketing team calls tech immersives, which are people who just want a robot buddy like me. And so we're totally doing that. We do a lot of play testing at Anki, as you may have figured out, and so we have people through like 5 days a week helping us tune that stuff up. So. Oh yeah, please go ahead.
Are you looking to solid-state batteries instead of using liquid or polymer batteries?
No, and the reason for that is that cost is a major driver for us, and so basically we have to get the most milliamp hours per penny that we can get. And so, you know, I love it, and I know it's going to happen because of, you know, especially electric cars and all of that stuff. We always want to tap what the most cost-effective battery technology is, and right now it's lithium polymer batteries. So. Okay.
So how did you find your manufacturer? Or did you make your own, or?
Oh, no, we had to find them. And we were a really small company at first. Right. And so basically, you know, I just spent months in China and basically met with more factories than I can remember. And we evaluated their capabilities and we got references, and it was a little bit like dating, I guess. We eventually found just the right partner, and they're still with us. So.
Congratulations.
Thanks. Okay, go ahead.
The display is really cool.
Oh, yeah.
Like, there's something sort of vaguely similar, like on Spark, on it's like a little OLED display about yay big. Is this something kind of like that, or?
It is, and like I don't think this is a trade secret, but anyway, we used for Cosmo. It's a straight up OLED, and it's pretty much the common kind you find on SparkFun, and it gave amazing contrast. It was super cool. For Vector, we wanted full color and higher resolution, and we couldn't do that with an OLED panel. So we ended up using like a IPS style TFT LCD panel, and it's actually great. The contrast ratios are really nice, and color reproduction is good, resolution's higher, all of that. So, okay, cool. Thanks, guys.
Awesome. So can people play with this?
I guess.
Okay.
I don't know what software is on it, but it appears to be on it.
All right. So we have this room until 10 o'clock when we get kicked out. Some of us continue conversations outside the parking lot. Feel free to come up and play with, this was Vector, right?
Yeah, it's Vector.
Play with Vector,
Yep.
ask Nathan some more questions. Thanks everybody for coming.